All right, so next I'm very excited to invite Jasjeet Sekhon to join me on stage. Jas leads AI at Bridgewater and is a professor at Yale. So please welcome Jas. Hey. All right. Okay. So just to dive right into it, you're an expert in causal inference. As far as I can tell, causal inference doesn't feature prominently in today's large language models. So can you tell us, what do you see the role of causal inference being in AI going forward, and how do you think that will evolve?
Great question, Robert. Thanks for inviting me. So I'm an expert in causal inference and machine learning. I've been doing that for like 20 years. So what's causal inference? Causal inference is an interdisciplinary field of study. It goes from computer science to statistics, which is about, hey, if you give someone a drug, did it causally make their headache go away, or is it just that people took a particular drug who happened to likely to have their headache go away? So it's a prominent thing in various fields, like medicine, obviously. In tech platforms, it comes up in recommender systems. Did an ad actually cause a change in purchase behavior, or do people who like purchasing books just happen to click on ads about books? So what's happened is, historically, if you take any machine learning algorithm, say, XGBoost or something that we just heard about, all the data is just like X1, X2, X3. The model doesn't know anything about the data. Everything it has to learn from, the covariance matrix or the higher moments. So there's not actually any causality in the statistical model. It has to come from something else, like you did a randomized experiment or something. What's been shockingly interesting about large language models is, there's some debate, but I think the following is pretty clear. We have benchmarks where you can show this. The large language models actually have a world model in them, built off of the corpus of human knowledge they've been trained on. So before they look at any quantitative data, if you ask them, hey, is inflation and unemployment more causally related to each other than, say, baseball statistics, they already know that. It's not like they have to go look at the tabular data and then try to figure out some correlation, which in any finite sample might throw them off. So there is a causal understanding of the world embedded in large language models. People have probed it in various ways. It breaks down in some ways, but not in others.
And so do you think that's something that will be emergent ultimately, or something that ultimately gets baked in?
Yeah, so it's already in some form, and then getting it exploited in an optimal way, in a way that's like in a production system, I think that's what people are working hard on. With my academic hat on, so I can talk about that work a little more openly, we've had like machine learning algorithms for like predicting intestinal bleeding. And the physicians, had some interest in it. They were all worried about its interpretability and everything. You hook it up to a large language model that is hooked to like clinical guidelines, and it represents the predictions of the machine learning model in a conceptual framework the physicians understand. Their prior swing to, this is great, we can engage with it. So I think a lot more of this is going to happen, especially in high stakes settings. Because until very recently, machine learning's had a big effect on the economy, but in things that don't really matter much. It's like ad targeting. If you get the ad I'm supposed to get, I got the ad you're supposed to get, A, we don't notice. B, if we notice, we don't care. And then that's quite different if it's drugs. If you got a drug I'm supposed to get and vice versa, we will probably notice, we care, our estates will care. So then there is more of a notion of like, what was the cause or reason that you made that prediction, and how do you safeguard it?
Makes sense. Mike touched on this a little bit, but what is different about AI in finance, if anything?
Right, so there is a set of things, is the future's not like the past, and there's finite amount of data. So, what's the standard machine learning pipeline? Hey, I want to tag pictures of dogs and cats. I'll get a whole bunch. If I exhaust the training set for somehow, I will get some more. I will go hire a company, and they will get some people to tag 1 million more images, and I get to go. And I also get to assume that the images in the future are like the ones in the past. So the usual textbook stuff you get, that I get to do cross-validation, divide up my sample, it all kind of like works. Now it has defects in it, like for example, even the image classification, so dogs are less docile than cats. So what happens is, part of how an image classifier categorizes as an image of a dog or a cat is the pixelization in a digital image. because cats' images are more zoomed in. So that's an artifact, right? So, so then this robust classification literature got started saying, well, don't use non-causal things. It didn't really it didn't really go very far, in fact, of influencing production systems because it just caused lower performance on average. And cats aren't evolving very quickly. They're going to be on average more docile than dogs, so they're going to be zoomed in more. But in finance, when the future is not like the past, it is a very adversarial setting. It is kind of like what was happening on the image platforms was people were adversariously finding every gap, every image, every distortion that's happening and exploiting it. So in finance, you have to bet, I think, more on causal structure and understand why the model is doing what it's doing, because people are going to exploit it.
Yeah. What are the areas where you are like really most data limited?
It is every area. It is one of the things about, like, say, large language models. They're very good in clinical medicine, like very good. Like the number of papers coming out that they outperform experts in the field is growing. The FDA has approved over 1,000 AI systems, mostly in radiology. I fractured my arm. A couple of months ago, I was sitting here in urgent care. The X-ray came in. I just loaded up to just ChatGPT, just the commercial thing, and said, "Hey, your arm's fractured. It's fractured in 3 parts. Less than 1% of fractures. That's complicated. You should go to a specialty center." Like that's like really good. The generative AI models are quite bad at finance, relatively speaking, because at Bridgewater, we're not publishing our best work in the open internet, so on and so forth. So the public training corpus isn't very good. So that's one of a big limitation. So you've got to, like, if you're going to use a large language model in finance, you've got to make it better. The funny way to say it is there's not a whole bunch of Reddit posts saying about how cholesterol is broken down by bile ducts, and the protein channels. Like there's not a whole lot of that. There's a ton of that for finance. The Wall Street Journal will contradict Bloomberg on the same day on the same fact. The quality of the pre-training corpus isn't very good.
Yeah, I think you can get pretty far with Reddit posts, but beyond a certain point, to like really become an expert in some area, the quality of the data needs to go up significantly.
Right. On the Reddit, you can get the sentiment, not the causality.
Yes. What about scaling in AI? Do scaling laws matter in finance?
I think they matter in finance as they matter everywhere. In the places that you have more data, the models just naturally will learn better.
And what are those places?
Well, higher the frequencies you go, less you have to worry about what inductive bias you're putting into your model. Every model has a certain amount of inductive bias. You want to put in enough so that the learning process goes, but not so much that it dominates as the sample size grows. So more data you have relative to signal to noise, less you have to worry about that. The longer the frequencies go out, more now you have to worry about exactly what bias you put in your model. Like, for example, if you have like a linear model, you have a linear inductive bias. So if the true functional form is linear with not a whole lot of data, you're going to get there much quicker if you assume linearity to begin with than if it was a more complicated functional form.
You mentioned you have more data for the higher the frequency is. Do you see AI becoming more of a game changer for high frequency trading or for longer term, longer horizon investment decisions?
Yeah, I think it's for both. In the higher frequencies, we've already seeing it, that many firms are moving from, you would hire people, they handcraft, mathematical trading systems, to it being replaced by, neural nets that get trained or some similar thing. So that's happening in the higher frequency thing. And if it's high enough frequency and the executions will be very fast, the nets get very, very small. And then the compute is on finding that architecture, so it becomes on architecture search. But once you have to execute, it has to be very quick. But in the longer term thing, the thing in many ways I'm like very excited about is, until generative AI came, there was no way I could give a tabular machine learning algorithm qualitative information about the world. But now with generative AI, if I say, hey, think like George Soros, or think like Buffett, you can create that. So this big divide that's been in finance between like discretionary traders and systematic traders, like I'm not sure how long that's gonna last. That crucially depends on your AI timelines. But you're seeing this in clinical medicine on the bleeding edge, in which that in experiment now, when people are like, oh, we're physicians, we can just look at the patient, we can diagnose that. You know, now that we're measuring it, AI is like beating the physicians more and more. But now that's a case where the training corpus is quite good, but I don't think there's any reason this will not happen in finance as well.
Yeah, you mentioned a lot about clinical studies and the medical side of things. Is that an area? That's an area you've given a lot of thought to as well. What are you? What problems do you think are what sort of near-term results or progress are you expecting to see there, and what things do you think will remain elusive?
Right. So in the nearer term, I think generative AI has really unlocked a lot of the barriers we previously had about implementing machine learning systems in patient care, because of it's very hard to guardrail them, interpret them, and now if you're going to deploy ML systems at scale, you want interpretability at scale. You want scale to work for you and not against you. And AI systems are using that. So you see a lot of major players in healthcare investing lots in that. Like everything, like as AI goes to the economy, if one asks what's the effect of AI in the economy, I'm much more bullish on how AI technology is going than I am on what its effect on the economy is going to be, and that's because there's a lot of bottlenecks in the economy. And one of the big places there's bottlenecks is our healthcare system. There's a lot of players who don't want to change. There's a lot of pre-existing winners in the system who will not want to deploy it. If you go to like a biotech VC conference, which I do sometimes, and you talk to the AI people, a lot of their panels are like, oh, we can't even get the data, we can't even share it, or get siloed. So those are things that I think are going to take longer. The human thing always takes longer.
Can you tell us a little bit about AIA Labs at Bridgewater?
Yeah, so I've been at Bridgewater since 2018. Before that, I was a professor at Berkeley, and I worked closely with a variety of large tech firms, the last of which was Facebook, Meta. So what brought me to Bridgewater was Greg Jensen, one of the co-CIOs at Bridgewater. Huge long-term interest in AI, and we both think that in order to use AI, particularly in the timescales Bridgewater is interested in, it's the world's largest macroeconomic hedge fund, is that you need a causal understanding of machine learning systems. So we've done various projects and at Bridgewater, and then in 2022 we decided it's time now to start an AIfirst investment fund and strategy. We've been trading since 2023. We took a significant amount of external money in 2024. And our key conceit is that's the part of Bridgewater that's going to do everything AI first, right? Because it's part of where the bottlenecks in AI are. How do institutions change as AI comes? And one of the ways to do it is you create a group within it whose job it is to use the tools at their maximum ability.
So can you help us visualize, AIfirst makes sense, but what does that look like on a day-to-day basis?
Right. So it's simple things, like all your trading decisions are made by AI systems. Humans are overseeing them to make sure they're not doing goofy things and fulfilling fiduciary responsibilities. But there isn't discretionary overlays on them unless something unforeseen happens, which it hasn't so far, notwithstanding the very exciting macroeconomic times we've been living through. But it's also at a level down and says, well, the way you make your technology stack should be like, how would you do it from a clean sheet of paper? Bridgewater's been around 50 years. It has lots of technologists. We've had hundreds and hundreds of millions of dollars in CapEx in our existing tech stack, and it's great. But then part of the conceits is, all right, what would you do if you're doing that from scratch? What would it look like?
Yeah, cool. You're building all of this out. Can you share more from an infrastructure perspective? What are the kinds of challenges you run into?
Right. Well, the first is, with my research hat, no matter how much compute I get, I will consume it all and then ask for 10x. So you are compute bound. There is no limit. And we're in the age of distributed computing, and we also have our proprietary algorithms. So they have, a pretty differentiated way that they want to scale. And Anyscale, which we've started working with over the last 12 months, has been like fantastic. First, like the open source community is amazing that we've been able to like contribute to it.
That's all of these people.
And make it, you all help us, and then we help the open source community, and that's been great. But the other thing is that, working with Anyscale has been like fantastic. Like we work with a lot of technology partners. We usually find their engineering teams, they vary in quality, shall we say. Yours has been, have been excellent. They've been like very engaged. Our compute, you'd say to our production systems has gone up, 10x over the past year. Like our individual researchers' compute clusters have gone up like 50x. We don't think our demand for compute is going to slow down anytime soon on that. In fact, we've liked the technology so much, and we're like, hey, some of our proprietary algorithms at the C level that we code them, we want to hook in a very direct way into the Ray system, so we can maximally exploit your scaling model.
Yeah, that's awesome. Do you think that set of challenges will remain constant over the coming years, or do you see new challenges on the horizon?
Yeah, I mean, the existing challenges will always get easier because people, it's like PyTorch was, better than, TensorFlow and so on and so forth. Those will get easier. The newer ones are going to keep on coming. Like we're such early stages right now on like you have a foundation model, you have smaller models, you've got to do all sorts of training on them, post-training on them. For example, I'd love to run a bitemporal large language model. So like, hey, here, I want to blind you from knowledge before before COVID, for example. Like how would you even like possibly do that? So I'm just like giving that as an idea of like, wow, that's like an interesting thing. We're such early stages right now of the kind of use cases we're going to want from this technology. Like even if the scaling law stopped and the models didn't get any better than they are now, the amount of work that we would have to do to get maximum economic value out of existing frontier models is immense. And of course, the scaling laws haven't stopped, neither pre-training one, nor the post-training one. So both of those things are happening at the same time.
You mentioned AIA Labs is a spin-out designed to figure out how to build an AIfirst investment company. Where are we in that journey? Is it sort of from the spectrum of very much figuring it out to we figured it out and it's ready for everyone to roll out? Where are we?
We're in the plane is in the air. It needs to go like faster. So there's like, we figured out what to do. You got to do a lot more of it. So if anyone wants to like,
what does it take to succeed with this kind of effort? If other companies here want to build an AIfirst, portion of their company.
Yeah, it's like it is. I think you have to have like a research mentality, because it's not like anybody already knows how to do it. You've got to like try. You will fail, and then you'll try again. And we're still failing and trying. And that, I usually tell grad students, that's why we call it research, because you spend most of your time searching, and you have to keep doing it, because most of what you do fails.
I never made that connection.
And you keep doing it. And the other thing is the incentives have to be aligned in a sense that, much like, bottleneck AI and the bottlenecks in the economy, it is you want to leap to the next level. And the other one that's hard, and it's very hard for companies to deal with this, is the bitter lesson, right? Like bitter lesson always hits ML researchers, let alone for-profit companies, because at any point in time when your system's doing something wrong, we've had it, it is always easier to just fix it as a one-off. Because I know what the problem is, I know how to fix it. And of course, when it's fixed as a one-off, you get to also be very clever, because it sounds also clever. And someone can come up and say, look at this very complicated algorithm I came up with. Am I not very smart? I fixed it. And then the whole lesson is, no, don't do that, because fix it in general in a way that's scalable, that takes advantage of the scale compute, data, and learning and search, because otherwise you will eventually just get blown past. And then it's very hard to like resist that urge to just tape it, bubblegum it for now.
So fix it in the right way, in the in the simplest possible way.
Yes, that's going to fix it in general, such that you're leveraging the scale of compute and data, not fighting it.
That's actually very relevant for a lot of the discussions we have about designing distributed systems, where simplicity is really a value. I want to ask you a little bit about policy. You've spent a lot of time thinking about AI policy. Can you give us a sense of the types of policies you've been most involved in? And I'm particularly curious about which policy decisions do you think are no-brainers, and which ones do you think are genuinely tough decisions?
Right. So like in AI, there's lots of policy issues you could be worried about. There's ones about like fairness and disparate impact. And the ones, we already have like legal regimes for them and people working on them. The ones that are new, that our system and society is having a tough time dealing with, is at the same time you have this technology that is, I believe, and many believe, will be transformative to the economy. And also possibly quite harmful, in the sense that like AI systems are more grown than created, right? So like we don't know why they actually work. They work if someone starts to tell you, they know why the scaling laws work. Please tell them to call me. I'd love to know. So they're very hard to govern. So how should you regulate them? Not because I'm worried about existing AI systems, but the ones in the near future. Much like you wouldn't trust like a company to audit its own books, you probably shouldn't trust the companies to audit their own models for safety.
And by the way, when you think about harm, are you primarily thinking about like existential threats? Are you thinking about job loss? Are you thinking about other effects?
Yeah, so like there's a lot of threats that technology can have. We have a pretty complete legal regime for most threats and harms that companies can cause. It's the more existential ones that one worries about. The systems that could have unintended consequences that are quite large. And you also then worry also on the policy side that you want to win the AI race. If it is a strategically important technology that's going to be used from everything from medicine, but also weapon systems, is not one that you want to lose. And some governments are facing this more acutely, like Europe is facing this pretty acutely. Europe lacks a single tech company with global reach, of the scale of say, a Facebook, a Google, an Amazon. Their policymakers realize this. This has not been great, for Europe, and you do not wish for that to occur again with AI. So how to navigate that to take the advantage, but to control the safety risks of it is a difficult thing. I mean, I think it's a no-brainer to do some stuff, right? You should probably someone should probably incentivize an ecosystem for oversight of safety of models, much like we incentivize auditing companies, so companies don't audit their own books.
And you mentioned auditing. Is there an industry or a domain that you think does this well?
It's a good.
That's a good sort of metaphor.
Yeah. The closest one probably is auditing of corporate finances and the revelations that companies have to do. And I think the Great Depression was a key part of this. The reason that U.S. publicly traded companies have pretty uniform reporting standards was the Great Depression and the crash. And then in that caused regulatory regime to arise with the SEC and everything else. With my social science hat on, I fear we'll probably take something like that before the regulatory regime actually comes about.
Yeah. So you mentioned winning the AI race. So I want to ask you about export controls for chips. Is that a good idea? Is it a good idea or a bad idea?
Well, it crucially depends on one's AI timelines. If you think the timelines are relatively short of like meaningful change in AI progress, say 2 or 3 years, then you would think it's a no-brainer to have pretty strict chip controls, because chip controls are about one of the few things that we have a comparative advantage on. China has all the energy it needs. It has great engineering and STEM talent. So the only real thing you have is the chips currently, so you probably want to restrict them. If you think the AI timelines are like longer than 5 years, well, then you probably don't want to restrict the chips, because all that's going to do is encourage a domestic chip industry that is behind, but they'll eventually catch up. There's no reason not to. So like it crucially depends on one's timelines. I think from where I sit, which is, I think you should probably err on the side restricting the chips right now.
So you have a lot more visibility into this. Is the way you just framed it, the pros and cons, is that how the debate is framed among the people who are determining these policies?
I fear there's 3 groups of people. There's first group of people whose AI timelines are quite short, so they're like, you must restrict the chips. I think there's another group of people whose AI timelines are longer, and they very rationally then say, oh, you shouldn't restrict the chips. All you're doing is encouraging a domestic Chinese chip industry. And there's a third group of people who can't see past the next quarterly revenue statement. I think it's the third group who's currently driving policy.
Okay. So what does it take? So what else does it take to win this AI race?
Well, there's talent. One of the big comparative advantages of the United States is we're the giant global sucking sound of talent as it rushes into the United States. This is like a major comparative advantage. We've had this comparative advantage since World War II, when Germany used to be the previous great sucking sound of global talent. German universities were by far the best in the world before World War II. That didn't last. Now it's us. You probably should not give this up. It is a pretty priceless comparative advantage. It comes from not only great universities, but great capital markets, so on and so forth. And so you don't give that up. And the downsides, our limitations is, it's power, right? It's that we don't produce enough power. Even if you had power, we can't even connect it to the grid. We don't build anything. If you want data centers in the United States, our permitting's got to change. It's got to be a national kind of effort to change that. We have the capital markets. We have the people. The question is, can we build with focus to do it and not undermine the large comparative advantages the United States has?
You said we have a big advantage on the talent side, or an advantage. I think everyone here, probably who works at a company, knows how much effort companies put into recruiting people. Would it make sense, do you think the government here should run a large-scale recruiting effort, like a very active recruiting effort?
Yes. So I was in talking with some group of officials in this Chatham House rule thing, and they were like, oh, we had a DeepSeek moment. Should we do X, Y, and Z? And I was like, well, 5 of them were IMO winners. I think you should have gone to the 5 IMO winners, given $1 million and given them a visa, and said you can bring your family over. That's probably the best. That was the best comparative thing you could have ever done, which is, maintain what used to be a large path that the most talented graduates, STEM graduates from China, would come to the United States. If you undermine that, well, it's not going to work out well for you.
Seems like worth a try. What else are you excited about beyond policy or your work at Bridgewater? What else do you spend time thinking about?
Right. So I do think that when we get these technological revolutions, a lot of what they do is they undo the old social arrangements that sometimes get slow and gummy. It's when you had Uber and you have Lyft, part of what they did is they disrupted the existing taxi markets, which had become really cartels and had kind of power. So with AI, it's going to disrupt so many industries. And the exciting thing is, well, what is this going to do to a lot of industries to clean them up? Right now, our news media, for example, is in a problematic situation. But you don't, because of what happened with social media arose. It really disrupted the business model newspapers, it's kind of disturbing because newspapers co-evolved with democracy, like both democracy and newspapers co-evolved in British coffee houses. So like when you got disrupted one part of that linkage, the sociological consequences might be disturbing. The cautionary tale also is social media is quite probably likely had negative consequences on the mental well-being of young people, particularly young girls. But when AI is now there, now could you like reconstruct the news media environment that's healthier, that's better? So like thinking those through, like education, like we've had this, like AI is great. Like this should, the thing about education is like how do you get students to do better things? Is like the number one thing we know works is one-on-one teaching. It just doesn't scale, but maybe it does with AI, that every student can have like an individual teacher that brings out the best in them, that teaches them at their level.
Yeah, I'm excited about that as well. Jess, I really appreciate all of your insights. This has been fascinating, and thank you so much. So please join me in thanking Jess. Yeah. Jess, thank you so much. Yeah.